Okay, so this next part is really important. You can already tell because it's in a box and there's big, bold capital letters. So that's giving you a hint this is important. So when you hear derivative, you think slope of the tangent line. When you hear slope of the tangent line, you think derivative. They are synonymous. You need to know this. This is a huge part of calculus. So when you hear derivative, what do you think of? You think of slope of the tangent line. When you hear slope of the tangent line, what do you think of? You think of derivative. They mean the same thing for calculus. So let's actually practice finding some derivatives, some derivative equations, and we're going to use that formula that we talked about before. The limit as h approaches 0, f of x plus h minus f of x all over h. So for the first example, we have f of x equals 2/3 x plus 3. That's our f of x. And so we're going to set it up. We're just going to write out this limit. Limit as h approaches 0, f of x plus h. That means wherever this x is, I'm going to go ahead and just replace it with parentheses. So we have 2/3 something plus 3. That something in this case is x plus h. We're just plugging in x plus h for x. And then minus, use your parentheses, 2/3 x plus 3. And it's all divided by h. So that's our setup. Now we get to do some algebra. Try to simplify this. We can't plug in 0 yet. We'd still get 0 over 0. So 2/3 x plus 2/3 h, just expanding that part, plus 3 minus 2/3 x minus 3 all over h. So take a look at that. What cancels out? So the 2/3 x and the minus 2/3 x, the 3 and the minus 3. So you should notice that the only term that's left in the numerator does have an h in it. It's 2/3 h divided by h. Again, if there's a term in your numerator that's left over that doesn't have an h in it, then you might have done something wrong, so you might want to double check that. For us, so this h is just going to go ahead and cancel. We don't have much else to do. So we just have the limit as h approaches 0 of 2/3, which is just 2/3. So what that means is the f prime of x is 2/3. So what's interesting about this is that this doesn't look like an equation. It doesn't have a variable in it like our last derivative did. And that's because this slope of the tangent line is always equal to 2/3. And if you think back to this equation, this f of x is linear. So that means it always has the same slope, has constant slope. It doesn't change like in a parabola or something like that. So it doesn't matter what x value we're at, the tangent line will have a slope of 2/3. Linear functions are the only ones that have that constant slope. That's the definition of a linear function. If we look at a parabola or something else, you're going to get an equation for f prime, like something with variables. So let's take a look at number 2. 1/2 x squared minus 2x plus 3. Think about it ahead of time. This graph is going to be a parabola. It will not have constant slope. Over here, the slope is negative. Over here, the slope is positive. So our f prime is going to have variables in it. Let's go ahead and set this up. Try to write small in this first part. We're not going to have a lot of space to do this one. Limit as h approaches 0, 1/2 x plus h squared minus 2x plus h plus 3. Again, wherever there's an x, you just replace it with x plus h. And then we're going to subtract all of f of x. Don't forget your parentheses. And then all over h. Okay, up here, don't forget x plus h squared is x squared plus 2xh plus h squared. You have to expand it. It's x plus h times x plus h. Don't forget this middle term. That's what everybody forgets. So we have to distribute the 1/2 there. 1/2 x squared plus 1/2 times 2xh will just be xh plus 1/2 h squared minus 2x minus 2h plus 3, and then distribute the negative. Negative 1/2 x squared plus 2x minus 3 all over h. So you've expanded, and now we cancel. 1/2 x squared minus 1/2 x squared minus 2x plus 2x plus 3 minus 3. Double check. Do all your terms that are left over have an h in them? So let's check. Limit as h approaches 0, xh plus 1/2 h squared minus 2h all over h. They all have h's in them. So what that means is we're going to go ahead and factor out an h from each term. So h times x plus 1/2 h, don't forget that other h, minus 2 all over h. And then those h's will cancel out. So we have limit as h approaches 0, just x plus 1/2 h minus 2. And then we can go ahead and plug in the 0 for h. Just make sure you're plugging it in for h. X plus 0 minus 2. So that's just x minus 2. And then let's rewrite at the end. That's our f prime. That's our derivative, x minus 2. So that means our slope is not constant. It depends on the x value. It will change depending on what x value you're looking at. That's why we have a variable. Okay, so the examples we've looked at so far, your derivative has given you an equation, and if you wanted to find the slope at a certain point, you just plug it in after you find the derivative. There's also an alternative form of the derivative. Let's take a look at that. It's the limit as x approaches a of f of x minus f of a over x minus a. Again, this is like your slope formula. y2 minus y1 over x2 minus x1. But for this, you're actually going to be plugging in the point a f of a. So this is the point you're looking at, a comma f of a. You're going to actually plug in the numerical values for that, and this answer will give you the slope exactly at the point you're looking at. So this equation here, f of x equals negative x squared minus 4x plus 1, is the same graph we were looking at on the other page. And so if you look back there at x equals negative 1, we had a y value of 4. So f of negative 1 is 4. You can also plug it into this equation and see. So in this case, our a is negative 1. So we're going to take the limit as x approaches negative 1 of f of x. So we're going to write the equation f of x, negative x squared minus 4x plus 1. And then we're going to subtract 4. That's the f of a. And then on the bottom, we're going to have x minus a, which is negative 1. Okay, so this is your a, this was your f of a. We're just plugging that in. And now we're going to simplify. So notice this equation doesn't have any h's in it. The h formula was just if you're finding the general derivative. We're finding the derivative specifically at a single point right now. So now this is just like what we've been doing before. We just need to find this limit. All right, so if you plug in negative 1 right now, you're going to get 0 over 0. So there's something else you need to do. What do you think we could do to find this limit? So hopefully you thought about it. You want to factor. So you can factor the numerator. Factor out the negative first. And then it's negative x plus 3, x plus 1, all over x plus 1. And I'm sorry, I forgot my limit out in front. Bad form. And we can see here the x plus 1s cancel out. So then we just have the limit as x approaches -1 of negative of x plus 3. And then since we factored and canceled, we can just go ahead and plug in the -1 for x. Make sure you're actually plugging in -1, not 0 like we were for the other examples. So that is -2. And this was the same as on the graph that we had looked at before. If you turn to the other page, we had seen that -1, that graph had a slope of -2. This is just an alternate way to figure that out. We found the equation first and then plugged in -1, but if you just want to find it at a single point, you could use this form. Usually, though, we're going to use the other form, the one that we were working on first. Okay, let's stop there and we'll pick up with some more practice.